Good morning and welcome to hear the latest news on the Sakati Copper-Nickel PGE deposit that is located in Lapland in northern Finland. The Sakati deposit is one of the most significant base metal deposits found in Europe. Good morning and welcome to hear the latest news on the Sakati Copper-Nickel PGE deposit that is located in Lapland in northern Finland. The Sakati deposit is one of the most significant base metal deposits found in Europe during the 21st century, and it was found by Anglo-American exploration team in 2009. The deposit is quite exotic for that it doesn't have any superficial outcrops, and it's hidden beneath the Viiankiaapa mire shown in the picture on the right-hand side. My name is Henri Hoytià. I work as a doctoral researcher at the University of Helsinki and also as a geologist for Anglo-American Sakati project. This presentation is about isotopic constraints in the Sakati deposit, and also besides me, there's a lot of people included in the working group. Please be aware of the cautionary statement of this presentation. I briefly walk you through geology in central Lapland. We are in a Paleoproterozoic greenstone belt that records geological evolution from 2,500 to 1,900 million years ago, starting from rifting of an Archean continent, formation of a shallow sea, and then deepening of the basin and formation of a deeper sea, which is then closed in latter collisional tectonic events. In terms of nickel-copper PGE metallogeny, the most important stage of this evolution is the passive margin basin, which coincides with a large-scale plume event beneath the basin at 2,150 to 2,050 million years ago. This plume event has produced voluminous ultramafic magmatism, so-called Central Lapland Komatiite-Picrite Association, and also several intrusions of ultramafic and mafic rocks. They are known as the Savukoski group. Also, rocks in Sakati deposit belong to the Savukoski group. So the Sakati deposit host rocks are ultramafic olivine cumulates with very nicely preserved cumulate textures as seen in the picture in the middle. These cumulates are flanked by komatitic lavas, which show a variety of volcanic textures of undercooling and cooling, including this kind of cooling breccias, fine-grained massive komatiite flows with olivine phenocrysts, orthocumulates with hollow hopper olivine grains, and also olivine spinifex. Estimated parental melt for these komatitic lavas and the ultramafic cumulates is low MgO komatitic or komatitic basaltic, ranging from 15 to 20 of MgO with Kd values of 0.3 to 0.33. The highest forsterite content we have encountered so far in olivine is forsterite 92. The ores in Sakati are massive ore lenses, which are surrounded by disseminated ore, and then stockwork veins in the shallow parts of the deposit, and also neck textured ore in gabbronorites, which occurrence of which is very much random in the deposit. So the massive ore types, we have copper-rich massive, nickel-rich massive, and pyrite-dominated massive ore, pictures of which you can see on the right-hand side. The disseminated ore and the stockwork ore and also the net texture ore in gabbronorites, they are all copper-rich. The typical ore assemblage is chalcopyrite, peartite, pentlandite, pyrite, magnetite, and the PGEs are mostly in tellurites. And what's important is that the ore is dominated by copper compared to nickel. The current resource of the deposit is 44.4 megatons with very good copper and nickel values. Uranium-lead dating of these kind of deposits can be a bit hard because there's not much minerals containing uranium or lead in these ultramafic rocks. However, in the gabbronorites, we were able to extract zircon and also titanite for age dating. Zircons from these gabbronorites yield magmatic ages from 2056.7 plus minus 6.6 to 2052.8 plus minus 2.9 with very good MSWD values. And these zircon ages are supported by a titanite age of 2050 plus minus 15 million years. As for thinking what these gabbronorites are, we think that they are contaminated hybrid rocks of komatitic melt and crustal assimilants based on lack in their 3D continuity, which is why we think they are not dikes, and also highly radiogenic initial strontium isotope in blatching clays. These obtained ages from uranium-lead geochronology are supported by rhenium osmium systematics done by Marko Moilanen and others from the Sakati rocks. They obtained an rhenium osmium isochrone age of 2063 plus minus 35 for the host rocks and ore, but for the ore only 1928 plus minus 16 years. This is quite interesting shift, and it also shows that these rhenium osmium systematics show a lot of open system behavior. The Sakati deposit is quite well sampled in terms of sulfur isotopes. Regardless of ore type or ore mineral, the sulfur isotopes are fairly homogeneous. So on the right-hand side, I present the sulfur isotopic contents in chalcopyrite, pendantite, perhotite, and pyrite, and they are mostly concentrated between 1 and 4. But what's important with these sulfur isotopic signatures is that they are clearly positive, indicating that when a depleted mantle value of sulfur 34 is minus 1.3, there must be crustal sulfur incorporated to these sulfide ores. We have also studied copper isotopic signatures of different ore types in Sakati. The copper isotopes are sensitive to redox changes during magmatic processes and later on. Most of the copper isotopic signatures in chalcopyrite in the deposit plot between 0 and 1, so they're very close to the mantle value, which is around 0. But we observe a trend in the nickel-rich massive and a shift in the gabro-hosted copper-rich ore from positive towards negative values. And this is a clear indication that there have been some redox changes during magmatic processes or later remobilization that has modified the copper isotopic composition. More evidence of remobilization and also crustal contamination is given by lead isotopes on the ore. So most of the lead isotopic data follows the lead growth model of Stacey and Kramers, but there are also some very radiogenic samples away from the growth curve, which have clearly evidence and indications of remobilization. And when looking at the data a bit more closely, we observe that there is actually a clear shift from the massive sulfides towards more radiogenic compositions in the veins, and veins in this case meaning the stockwork, copper-rich stockwork vein ore and the copper-rich ore in gabbronorites. And this is an indication that these stockwork and gabbronorite ores, they have been crystallized from a melt that has had much more crustal component in it than the one with massive sulfides. When looking at plausible external sulfur sources for the ore in Sakati deposit, there are quite a few evidence of meta-evaporitic rocks in the Sakati deposit. So within the cumulate package and in the basal parts of the cumulate package, we have these anhydride carbonate rocks, so number 1 and 2, which show this kind of massive anhydride layers, and also these anhydride carbonate breccias with anhydride dolomite, magnesite, and albite. Below these cumulate package and the anhydride carbonate rocks, there are also a metasedimentary unit which displays anhydride layers within the S0 bedding. There's also a lot of evidence of prominent magma country rock interaction, as there are a lot of inclusions of anhydrides within the cumulates and also in the ore. And there's a picture of one inclusion shown in the number 4. In the hanging wall, there are also massive dolomite, which is very nicely showing the primary bedding. And that massive dolomite is hosted by a very heterogeneous carbonate breccia, which we call the red breccia, as for the characteristic color of that rock. And we think that that might be an evaporite dissolution breccia. So studying these meta-evaporites a bit more closely, we performed carbon and oxygen isotopes on carbonates of these rocks. And what we found out is that we actually have primary values and then a hyperbolic trend towards modified values, which is evidence of fluid rock interaction. These primary values are mostly preserved in the massive dolomite and also in the dolomite within the metasediment, but also in magnesites of this anhydride carbonate breccia. And most of the modified values are actually dolomites found in this anhydride carbonate breccia, and one dolomite of an inclusion found within the olivine cumulate. And this carbon-oxygen isotopic data shows that we record this high carbon value Lomagundi-Jatuli excursion, which is characteristic for paleoproterozoic carbonates of 2.3 to 2.05 gigaannum. Sulfur isotopes in anhydride in these meta-evaporites show highly positive 34 sulfur signature, mostly between 8 and 14. These values are a bit higher, but on average in line with other reported sulfur isotope compositions from the paleoproterozoic evaporites in Onega Basin and in Peräpohja. And what's most important is that these, based on sulfur isotopes, these meta-evaporites are the only rock type within the Sakati deposit lithology that has highly positive 34 sulfur signature, and hence these represent a plausible source for sulfur for the Sakati ore. Finally, to conclude, the Sakati deposit is one of the most significant base metal discoveries in Europe during the 21st century, and the deposit was found by Anglo-American in 2009. The deposit contains massive disseminated and vein ore types, which are hosted by olivine cumulates with low MgO comatitic to comatitic parental melt. The deposit is much more copper than nickel rich. Based on uranium-lead geochronology on zircon and titanium, the age of Sakati is on average 2054 plus minus 6. This age is obtained from gabbronorites, which we interpret as highly contaminated hybrid rocks of comatitic melt and assimilant. The 34 sulfur isotopic composition of all ore types is fairly homogeneous, but clearly positive and show incorporation of crustal sulfur into the system. The 64 copper isotopes evidence redox changes in the nickel-rich massive and also in the copper-hosted copper-rich ore. The lead isotopes indicate higher level of crustal contamination in the copper-rich stockwork and copper-hosted ore compared to the massive ore. The Sakati cumulate package contains several anhydride-bearing rock types and evidence of prominent magma country rock interaction. These anhydride-bearing rock types are most likely preserved pieces of paleoproterozoic evaporites that record the highly positive paleoproterozoic carbon excursion in carbonates and so very positive 34 sulfur signature. And based on that positive sulfur signature, we think that these evaporites are a plausible sulfur source for the Sakati ore. As this was a record talk, please, if you have any comments or questions to my research, contact me at my email. Many thanks to Anglo-American and K.H. Renlund Foundation for financing my research. Thank you.
So if he's not online, so we're going to move on to the next speaker.